Chapter 10, Graphical User Interfaces, Part 2. So we can create our JFrame, which is a filled frame, which references a filled frame. Once main has the instantiated filled frame, non-static instance variables and methods can be used. So we can use, from frame, we can use non-static instance variables and methods. Until we instantiate an object of type JFrame, we can't reference any of the non-static instance variables or methods because non-static only exists when an object of the class exists. Conversely, static exists even when no objects of the class exist. So non-static, we have to have an object. Static, we don't have to have an object. In modern GUI programs, the user controls the program through the mouse and the keyboard. So it's responsive to events that happen. The user's going to click, the user's going to drag, the user's going to hover, those types of things. The user can enter information in text fields, can click on menus and pull down menus, and have cascading menus, click on buttons, drag scroll bars, and so on. The program must be responsive to these events that the user is initiating. The programmer can choose which events to respond to and which to ignore, such as mouse move or a button push or click, those types of things. So a program must indicate which events it wants to receive. Which ones am I going to handle? And it does so by installing event listener objects onto the things that it wants to be responsive to. So an event listener object belongs to a class that you declare. So you're going to create a class for this. The methods of your event listener class contain the instructions that you want to have executed when the events occur. So the listener is like, okay, I'm going to respond to this event, and then you have to write the code in there that says exactly what you do when that event occurs. To install a listener, you need to know the event source. Where's it coming from? For example, clicking on the OK button, clicking the cancel button, whenever the event occurs, the event source calls the appropriate methods and all the attached event listeners. Here's an example of the action listener interface. Again, interfaces were in chapter 9, which we skipped because they're not part of our course objectives. So you just have to type it up as is. You don't have to worry exactly about how interfaces work. But notice at line 7 in this example, we have public class click listener implements action listener. So it's going to implement the action performed method. When we say implement, implements is a key word saying that it has to follow the model in the interface action listener. But when we say implement, it means write the code. Look at the code at line 9. Public void action performed, action event, event. And inside that method, all it's going to do is say, I was clicked. It's just like a stub method. It's just showing that works rather than actually doing something constructive. We can ignore the event parameter. It has information such as when the event occurred. We don't have to use it inside our action performed event method. So you have to register the action listener. So a click listener object must be created and then registered, added to a specific source. So action listener equals new click listener, and then we have to add it to the button.add action listener. That ties the two of those together. Now whenever the button object is clicked, it will call the listener.actionPerformed by passing it the event as a parameter. So what event was it? The clicked event for that button. Here's some code for button frame1.java. I encourage you to hit the pause button at this point and feel free to type this up and implement it. Notice there is no main method, so you will need a tester class as well to create one of these button frames and implement it. Here's an example of our button viewer 1 that creates a button frame and then sets the default close operation and then sets visible to true. We didn't set the size. Oh, there's the size. Look at it right there at 11 and 12 is where we create the constants, and then at line 17 is where we create the size. Inner classes for listeners. An inner class is a class that you create inside another class. In the preceding section, you saw how the code that is executed when a button is clicked is placed into a listener class. Inner classes are often used for action listeners because we don't want to create a separate class for them. We can include them in the class that's going to use them. So it's declaring a class inside another class. There are two main reasons for creating inner classes. One, it places the trivial listener class exactly where it's needed without creating an extra file inside the project. And number two, methods can access variables that are declared in surrounding blocks, so we don't need to pass them in as parameters. In this regard, inner classes declared inside methods behave similarly to nested blocks, such as a nested loop or a nested if statement. Here's an example of an inner class listener. In button frame 2 extends JFrame. Then we've got our instance fields, private J button, private J label, label. And then we've got our inner class, click listener implements action listener, and so on. Here's an example, and you might want to hit the pause button and type up button frame 2.java, or go to the student companion for our textbook and download that code and try to get it running. It's a useful activity to actually run the code and see how it works.